Hey everyone, so today we are going to be talking about box and whisker plots, okay? Also just called box plots. So here you can see we have a box plot, okay? And so we're going to talk about how to find all the different parts of it, okay? So here you can see this is going to be your minimum value, okay? Your minimum and maximum value are always going to kind of be lines at the end of your box plot, okay? These parts, right, are called the whiskers, okay? And the whiskers go from the minimum value to the start of the lower quartile, which is Q1, okay? And then we have the box, which is our interquartile range, right? And we said this here is our median, okay? And then this is our upper quartile, which is Q3, okay? And so if you remember our interquartile range, I talked about this a little bit in the central tendency video, but our interquartile range is going to be the range of the middle 50% of the data. And so we can find that by doing Q3, which is our upper quartile, minus Q1, which is our lower quartile, okay? And so the way that we find the different quartiles is first we need to arrange the data in ascending order. Then we need to find the median of the data. Then after we find the median of the data, we want to find the median of the lower half of the data. So looking at the data from the start to the median of the data. And we want to find the median of that mini set of data, and that's going to be our Q1. And then we're going to do the same thing with the upper half of the scores. That's going to give us our Q3, okay? And so we can look here at this set of data, right? And so students were asked to report how far in miles they each lived from school. The following distances were recorded. So we can look at this table. And if we look at the next page, we have some questions, okay? So they are nice. They're going to give us all of the information, okay? They want us to construct a box plot for the distances and then describe the main features of the distribution, okay? So that is going to look like, the first thing we want to do is construct our number line, right? So they tell us the minimum is 0.4 and the maximum is 7.5, so we need to make sure those fall on our box plot. So I'm going to go from 0 here to 10 here. Okay, so I'm going to go from 0 to 10. I'm just going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and then I'm going to label those. Okay, and because our data deals with a lot of decimal places, I'm also going to just make the 0.5 increments on my line just so that it makes it easier to see. Okay, so now my first step is I'm going to plot my min and my max, okay? So my min is going to be 0.4, so that's going to be about right here, and I'm going to draw a nice tall line like that, okay? Now I'm going to draw my max, okay? That's 7.5, that's going to be right here. Okay, so those are the ends of my whiskers. Now I need to figure out how long I am going to make my whiskers, and I'm going to do that by drawing my interquartile range. Okay, so remember that's the IQR is Q1 to Q3. Okay, so they tell me my Q1 is at 1. So that is going to be right here. Okay, and it goes until Q3 is 4.3. So that's going to be about right here. Okay, so now I'm going to draw a box, and then I can draw my whiskers from there. Okay, now I also need to draw my median at 3, right there. Okay, so that is how we draw a box plot. Alright, so now we are going to look at question number 2. Okay, John currently lives furthest from the school. Would you consider his distance from school to be unusually far compared to the others? Okay, so if you want to look back on the other page, we can see that John lives 7.5 miles from school, okay? And so as we talked about with outliers and skew, we know that outliers are found when they are either they're 1.5 times the IQR above the Q3 or 1.5 times the IQR below Q1, right? So the first thing we need to do is calculate the IQR. Okay, and so remember that's going to be our Q3 minus our Q1, right? Okay, so that is going to be, in this case, 4.3 minus 1.0, which is 3.3. Okay, so that's our IQR. Now we need to multiply this by 1.5. So we have 3.3 times 1.5, okay, and that's going to equal 4.95. Okay, so now we need to add this to our Q3 and subtract it from our Q1. Okay, so I'm going to do that over here. So my Q1 is going to be minus 4.95, okay. That's going to be 1 minus 4.95, which gives us negative 3.95, okay. And then we're also going to do Q3 plus 4.95, and that's going to be 4.3 plus 4.95, which gives us 9.25. Okay, so that tells us that if anyone lives more than 9.25 miles away from the school, that's an unusually long distance. Okay, so therefore we can say that John does not live an unusually far distance compared to the others because he is not one of those outliers. So I'm going to say no, because only distances further than 9.25 miles are unusually far. Okay, so now we're going to look at question number 3. John's family is considering moving to a house that is 10 miles from school. How will this move affect the summary statistics? Change John's distance from 7.5 to 10 miles and complete the table below based on this new data. So now John's distance instead of 7.5 is going to be 10 miles, but that actually doesn't change most of this, right? Because our minimum is still going to be 0.4. Our maximum now is just going to be 10, right? But we didn't actually change the number of entries that we have, so our median is still going to be 3. Our Q1 is still going to be 1.0, and our Q3 is still going to be 4.3. The only statistic that actually changes because of this is going to be our mean, okay? So if we add all of those values up and divide by the number of values we have, we end up with 3.22, okay? So if we look, has the mean increased, decreased, or remained unchanged? Our mean has increased, right? Okay, and the reason of that is that the sum of all of our distances increased, right? Instead of adding a 7.5 as the last value, we now added a 10, right? So the sum of all the distances increased, causing the mean to increase. Okay. Now, has the median increased, decreased, or remained unchanged? It's remained unchanged, right? Because we didn't actually change anything. We didn't change the number of entries that we had, and so if we were to cross them out on each end, we'd still end up with 3 as our center. Okay, so now they want us to make a new box plot based on this data. Okay, so now I'm still going to go 0 to 10. Okay. my box plot here is a little longer than it needs to be, but that's fine. It goes on forever, right? And then I'm going to make my half indicators again. Okay. And so we're essentially going to graph it mostly the same, right? Because our minimum is still at 0.4, so I'm going to have that line there. Okay, my maximum is now at 10, so that changes slightly. Okay, my median is at 3. Okay, that line is going to be there, and then my Q1 and my Q3 are at 1 and 4.3, which is about right there. So I can draw my box just like that. Okay, and then I can connect my whiskers like that. Okay, now one thing that's important to note is that this is not the correct way to draw a box plot with outliers, okay? Alright, so now if we go ahead and take a look at the next page, we have some more questions. Okay, so was John's distance from school considered an outlier before the move? Defend your answer mathematically. Well, we kind of already talked about this, right? Because we found that the upper fence, in this case, was 9.25, right? And we calculated that by doing 1.5 times the interquartile range, and we added that to our maximum, or to our third quartile, okay? That's what the upper fence is, okay? And so 7.5 is less than 9.25, right? So no, okay? And then what about after the move? Well, after the move, 10 is now greater than 9.25, right? Okay, because our IQR didn't actually change, so it still equals the same thing, and so now 10 is greater than our upper fence. So yes, John's distance is an outlier. Okay, so now let's look at Zane. If you turn back to your table, you can see Zane was the closest, right? Zane lives 0.4 miles from school, okay? So now let's look at whether Zane was an outlier. If you remember when we calculated our IQR and our upper and lower fence, our lower fence was negative 3.95. Now, technically speaking, we can't have negative distances. That's not how the real world works. And so Zane, he lives 0.4 miles away from school. And so his distance is not considered an outlier because the outlier would have to be negative, which we can't have negative distances, so there is no such thing as an outlier on that end of the spectrum. Okay, so now we're going to construct a box plot like we should have properly. Okay, so we know that 10 miles is an outlier. And so what we're going to do is we're going to still draw our number line from 0 to 10. Okay. Okay, and then I'm going to draw my half indicators again. Okay. Okay, so now what I'm going to do is I'm going to start out the same way I did before, right? So I had my minimum at 0.4. I'm going to draw that there. I know that my Q1 is going to be at 1. I know that my Q3 is going to be at 4.3. okay? And then, so I'm going to go ahead and draw that box and that whisker. I know that my median is at 3, right? That all still hasn't changed. Now, this part is the part that changed, right? And so, if we ignore, right, because John is now an outlier, so we're going to ignore his data point for a second here, which means that my whisker is actually just going to end at 5, okay? Just like that. And then what we're going to do is we're going to put a star over here, or a dot or something over here to show that John also has a data point there, but it's an outlier, okay? So that is how we construct box plots with outliers. All right, so now let's go ahead and look at this example problem. Okay, so they give us a list of data, and then they want us to find the outliers before making the plot. Okay, so the first thing that we need to do is we need to list the numbers in ascending order. Okay, so if we do that, we are going to have 1, 11, 11, 12, 13, 14, 17, 17, 17, 19, 19, okay? So first I need to find the median, so I'm going to start crossing out on either end. Okay, so I find that 14 is my median, okay? Now I need to figure out where my Q1 and my Q3 are, right? So now I'm going to start over here, and just looking at this set of the data, I'm going to cross out 1 on each end until I find that 11 is going to be my Q1. And then same thing over here, I'm going to cross out 1 on each end until I find that 17 is my Q3. Okay, so we found our Q1, our median, and our Q3. Now we need to check for outliers. Okay, so to do that, we need to find our IQR. Okay, so that is going to be 17 minus 11, okay? And that's going to give us 6, okay? So then if I do 6 times 1.5, that gives me 9. So now I need to add 9 to 17 and subtract 9 from 11, okay? So my upper fence is going to be 17 plus 9, and that is going to give me 26, okay? And then my lower fence is going to be 11 minus 9, and that's going to give me 2, okay? So now if I look back at my data set, I can see I have a 1 here. This one is going to be an outlier, okay? So now I have all the information that I need, and I can start constructing my box plot. Okay, and so because I have 1 and then also 19, I need to go all the way from 0 to 20 for this. Okay, so I'm going to go by 2's here. Okay, so then I have 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay. And then my little subdivisions this time can count as 1s. Okay? So now what I'm going to do is I'm going to start with my Q1, right? That was 11. That's going to be right here. Okay? Then my Q3 is going to be 17. Okay? So I can draw that box. Okay? Now, my median is 14, so I'm going to put that line there. Now, for this side with the whiskers, normally we would draw the whisker until the next lowest data point, right? But I have 11 right here, and then 11 goes straight to 1. But we said that this one was an outlier, so this side is actually just not going to have any whiskers, okay? But we can put that outlier over here at 1, okay? And then on this side, our biggest data point is going to be 19, so we're going to draw that whisker and put it there, okay? So that is what our box plot is going to look like with outliers with this data.